Okay, so yes, I'm Christoph. I am allowed to call myself a professional Unity XR developer. So, Unity tips and tricks. So the name of the talk, but I'm going to start with a little bit of a backstory. So I learned Unity in 2019 for an internship here at LMU, and I took part in this very practicum in 2020, which was the remote edition, actually. You definitely remember that. And in a group of 4, we created a VR multiplayer game. That's the university part. So 3 of the members from the practicum in 2020 decided to keep working on the game, and we, did a little bit of development for a few months, and we actually presented it to a local app and game company, and in the end we got hired. So that's kind of nice. The project was immediately cancelled. And then, thankfully, our skills and the team has been put to another use in new projects. So basically, we've been recycled in that sense. The first thing we actually did at this company was a prototype for a VR puzzle game. And it actually worked out quite well because we were able to then, in the second phase, do the actual game. And it's on Steam and MetaQuest right now. It's called Labyrinth Deluxe: A Cruiser Quest. And it's a VR puzzle game in a very like a retro pixel art style. The third project we worked on at the company is a mobile game for a museum. It's also live on the app stores now. It's called Unite in Taste, and it's a mix of 2D and 3D. And then the latest project I was working on is a small AR app about architecture. And this was not published, but it was featured in the newspaper. And in fact, my primary school teacher, I ran into her on the street recently, and she said she recognized me in the newspaper. So that's something. A few words about my workplace now as a Unity developer. This company started up in 2018 and was going to work on a VR game or VR games of their own. And kind of the necessity of earning money then led to this company becoming a marketing or an app agency. You can't really make a game without paying the developers, and so we use the client projects to finance the own ideas afterwards. In 2020, I joined as a worker student at 20 hours per week, just like my colleagues did, and I'm now actually in full-time, which is surprisingly more relaxed than a part-time job, because you just have a little bit more time to do everything. The projects can change frequently, but the team does make it work. And this is a link. You can't really click it right now, obviously, but there's a link there if you're interested in maybe pursuing Unity as a career later on. Funny note about this, by the way, I say don't hesitate to walk into the office here. I mean this, because I got my colleagues and me the job by walking into their office and just showing them the game. So, just some inspiration there. This might work for other companies. Okay, well, enough talk about work. Let's talk about Unity. The best Unity tips. I have 3 for you today. Let's start with the first one. Maybe you can guess it. You can create blank in Unity. Any guesses? Everything? Okay, good guess. Almost got it. Any other ideas? What can you create in Unity? You can create games, okay? Anything more specific? Or something completely different, maybe? Maybe I should have asked, what can you not create in Unity? Do you know the answer?
Well, you can't handle the backend side of things, so you have to do that separately.
Okay.
And connect it to your project.
Okay.
I would say...
That's incorrect, but that's okay. You can create anything in Unity, you got it. I was just teasing you. So I think you can create anything in Unity. Because of the second tip. In Unity, everything is 100% blank. What could be the blank here? In Unity, everything is 100%. It's hard, I know. Well, it's 100% made up. As in, you can control it with code. And in fact, you can control all of these and many more systems using code in Unity. So, basically the sky is the limit. Tip number 3, what do all these games have in common? Bit of an easier one?
Unity.
Yes, you got it. Well, all of these are made with Unity, and the great thing is all of these are pretty well known and pretty successful. The other side of this coin is that there's also lots of games nobody has heard of that are made with Unity, like the one we made at work. So, those were 3 Unity tips. Let's move on to tricks. Because those were just the tips. So, the best Unity trick is that Unity tricks you into believing that it's simple, which it's not. But it's really easy to get started with and create games with it. So, okay, the best Unity trick for real though, what is it? Well, I think it's this. It's not completely the right graphic, but it's the component architecture basically. Almost every class you write in Unity has equal access to the runtime of the game engine. So it's very easy to add features and react to changes dynamically with these component callbacks. And it's very small for you right now, but I'm going to go into it in a few minutes. All of the white boxes in the middle are these callbacks that you can use. Understanding them is basically the key to this trick. And then, is it easier than it looks? I thought I deleted the question mark, but let's find out. The first thing that happens when the game launches is something that I think is underused in games, and it's the runtime initialize on load method. You can add this to any of your scripting methods, and there's a few parameters. And basically what happens is when Unity starts up, you immediately get this callback. And then you can do whatever you want in the static method. For example, the Steam VR runtime launches with this callback. The XR plugin management, ARKit, the sound management in the game from work uses this to load the data, then creates a global singleton, and the analytics frameworks you'll find for Unity also use this. So very useful. When a scene starts, you have these very important calls, awake and start. I will go into that in more detail, but basically you can see the red arrows here. This is the top one is start, and then while it's running, the update is the second red arrow there. That is also a very important one. So let's look at it in slightly more detail. Though I could spend hours just on this diagram alone. It's included mostly for reference, and it's obviously too small to read here, but let me go over the most interesting parts. So these white filled items, as I said, are the callbacks on a C# class. And the gray items are Unity engine internals, so you don't get those callbacks. On awake is when the script is instantiated. Sorry, did you have a question? No? Okay. So awake is when the script's instantiated. That means your object has been created. You don't get a constructor call, you get awake instead. And all of your properties that you put in the scene or in the prefab are already there. We'll see this in a second. On enable, it's kind of misleading here. It's just like immediately below. It's actually could be quite some time later, because this is called when your object actually gets it's not only loaded into the scene, but it's actually going to become active. And after this, it gets the start, which means that now this is the last chance to do anything before your object's going to be rendered in the scene. And it's only called once. It's very important to know as well. So let's move on to the center part here, the physics. Physics is basically made up of this FixedUpdate call. You get this before the physics are calculated for this frame. And there's a fixed amount of time between these calls. So this is stored in the project settings, but interestingly, it can be changed at runtime. And this basically you can use to change how accurate or how fast the physics simulation runs. So after the physics are computed, which is in this big internal physics update here, you get some more callbacks before the fixed time passes. So let's say the default is like 50 FPS, I think, for the physics loop. So you will get another callback before the 50, the 0.02 seconds is waited. At the end, you get these callbacks, and you can react to things that just happen in the physics simulation. So you get on trigger and on collision, so the collider is going to intersect, or just intersected rather, and you can also wait until the very end here if you need to, and then see what actually just happened. Moving on to the game logic, this is the update loop, and everything that's not related to physics should probably be in here. It's so like in UI update, a small animation to the UI, maybe user interaction, starting a download. Don't put little long action in the update though, because update is basically holding up the rendering. So if you're downloading a 5 GB file, your user is going to sit in front of the screen that's not updating for some minutes. So definitely use an async function for that, or maybe create a task. But I would avoid creating a known thread unless you know what you're doing. And then in a late update, so at the bottom here, when the animations are finished, you can also do something before the GPU gets to render the frame. Okay, so scene rendering. This is something I actually just discovered when I was making this talk. I don't know if it's new, I don't think it is, but I've never used it. It seems like the post-processing is done in this part, in the top here, because you can actually get access to the image that a camera has just rendered. So different possibilities there, may be interesting. The gizmo rendering just below, this is really only for the editor, so you don't really need to worry about it, but you could put stuff in the scene window if you want to, in the gizmo. The on-GUI, that's a thing that's mostly for desktop. It's a 2D UI that's simply rendered on top of everything. So you could put like an FPS counter maybe, but it doesn't really work on a headset because it's going to be like here. So just keep that in mind. And here we go with the misleading diagram, I guess. So you can see at the bottom we have this kind of undestroy, so undisable, undestroy, and then it loops back around to fixed update, I think. Or maybe, yeah, I think it does, which is maybe not correct. So the undisable is called when your object is no longer part of the scene. So it could be just actually deactivated, or it could be destroyed. And on destroy, that means that your object's just actually been deleted. So you need to free up the memory if you have anything going on, and then get out of there. But you could get on disable and then on enable again. Because, for example, let's say you have something that just went off screen, and then you want to use it again. So you just keep it in memory, you disable it, you put it back somewhere else maybe, you enable it again. So you didn't actually get on destroy, because you're reusing the object. So I don't know why they don't have this in the diagram. It could easily go from on disable to on enable again. Importantly, it doesn't get start, because it has already started once. The object doesn't start again. It kind of just unpauses if you want. Okay. For this next section, special thanks to my boss, who allowed me to use the code from our published VR game. Right, so the energy system, yes. It's a system from the puzzle game where basically it conducts something like electricity, but it has a color property, so it's not really electricity in that sense. It's some kind of made-up energy, and you have cables and connectors and stuff that you can plug together in the level editor, and then you can power something with it. And there's an energy source, like a solar panel, and then there's also an energy sink, so something that needs the energy. And that could be a door, or it could be a light. Let's see what the code looks like for the energy source. This is an abstract class, and this is not the entire thing. I omitted something at the end, which is not super important right now because it doesn't make sense if you don't know the whole system. So let's go in more detail. Anybody know what the 3 slashes mean for the public abstract class? Yes.
That describes the whole class, and you can also generate documentation on it.
Perfect, exactly. This is the class documentation. So 3 slashes, you can document a class, or as you can see, you can document a field. And in the IDE, it will show you this with the mouse over as well. If you mouse over the name of the class, it shows you this. So very useful, especially if you're working in a team, to write something so that other people know what it means. Then we have the class declaration, which means in this case we inherit from MonoBehaviour. That's your standard Unity class. If you create a new C# file, it's always going to be MonoBehaviour. This has all of these callbacks that I was talking about earlier. And the energy source is something from our game, which is, in this case, it's an interface. So that's why it has the I in front of it. And this means, okay, this is an object that can provide energy into the system. Let's see, what else do we have here? Yes, documentation comments. That's important to use 3 slashes. 2 slashes means a code comment, and that's not going to be shown in the IDE. These things with the square brackets, if you haven't seen these before, this is a C# attribute, very important in Unity. I'm not going to go into it, but basically you can just use it like in any of the tutorials and stuff. I don't understand how it works, so that's why I'm saying you can just use it. These ones that I've put in here, I know what they do though. I don't know why they do it, but they do something. And then the thing at the bottom where it says event is like a delegate, this is something I can recommend to all of you for some very fast prototyping. Put lots of Unity events. This energy event is just a subclass of Unity event in your objects. That way you can, if you want to, you can use them in the inspector and drag method calls around, and you can react to things happening very dynamically. Okay, so this is how the script appears that we saw until now. This is how it appears in the editor UI. So, by the way, don't worry if you haven't opened Unity before. It's very simple. You just double-click. So a common misconception is that to have something show up in the inspector, it needs to be a public field, which in this case you can see none of these fields are actually public. The only API that this energy source behavior provides is the interface that's implementing. That's public. So we've made these appear in the inspector using the serialized field attribute. And as you can see, this from line 12, the mesh renderer attribute is the field is listed here, and I've assigned the renderer, and then the material index integer is also shown right there. And the other protected ones are not showing because they don't have the serialized field in front of them. So serialized field, what it does is then all of these values that I've put in the scene or in the prefab, they are going to be populated in before awake. So in awake, let's look at that. I can already check, has somebody actually put a mesh renderer in there? Did the tech artist basically do the job or not? And if they did, so I have the mesh renderer, for example, I can get the material color here. These are the runtime methods. So awake, we already saw that. Serialized values are available. Start means the gameplay is about to begin. So in this case, what I do is I basically flush the cable once. I put the energy all the way through by just calling every of these energy events. These are going to all link together, and whenever the energy changes, then it's going to be set in the next connected object. And then in FixedUpdate, this is the physics time step. So in this case, we check if the energy is changed, and if it has, then we need to, we can change the effects. So basically, this is a feature flag in our game that tells us, do we actually have, are we showing the changing of the color of the cable or not? And then after that, we invoke the event. So that means, oh, I've got new energy. I need to pass it on because I'm an energy source. And the previous energy, this is just so that we know if it's changed in the next frame. And you might be wondering, where's get energy? This call I'm using all the time. Well, it's not there because this is an abstract class. So the get energy is not implemented. And so I can make any kind of energy source, like, for example, the solar panel. Okay, so I think we have some time left, so I'm going to actually go into this next part. There's a problem here. this code could create visual lag. And let's explore why. We're back to our misleading diagram from earlier. There's another misleading part here, and it's actually mentioned, sort of. Let's see if I can... well, I'm going to read it to you. The physics cycle may happen more than once per frame if the fixed time step is less than the actual frame update time. Okay, well, what it means is that sometimes the physics is faster than the rendering. So you might get multiple fixed update and you don't have an update in between. Even though in here it's going like this, there's also this one, right? Okay, well, why is the diagram misleading? Well, it can be the other way around as well. So in VR, the headsets update at 90 to 120 FPS. But the Unity default physics update is at 50 Hertz, so times per second. And that means the physics are updating much slower than the display. And usually that's fine because the physics are interpolated, but for us this creates a problem. We have a Boolean value. And the energy source event is in the fixed update. So if we do the math, there could be 45% of lag between when the actual state changes and when the next frame is rendered that can take advantage of this in the next object. So if we have like a line of objects, there's going to be a significant delay after maybe 90 objects. Depends on the frame rate. What could be the solution here? We could move it to update. So update, as you might recall, this is for every frame, so 90 FPS, 120 FPS, we get this callback. Cool. We just move it, right? Easy, just remove the fixed. Done. Does that sound good?
Not just use an event to trigger every time the energy changes.
I do. But it changes the Boolean value in the object. And then whenever I'm in the frame, I can actually do something because I don't need to. Basically, the idea is I don't need to react earlier. I can pass it along between the objects, so it's kind of a chain still. It shouldn't be. It depends on your game design. We'll get there. But that's okay. We could actually change it by just having a cascading event, depending on how many like objects you have. It could create a Stack Overflow. So there might be a level design issue at some point because we have huge levels. So okay, well, this code could now break the physics, unfortunately. So we're in update, and we are doing, once again, back to the nicely made diagram here. We have the possibility of the faster physics update. So what it means is, what it means is we could have the situation where there's an update, so the frame up. Actually, this is incorrect. So a slower physics update should say at the top. You could have multiple frames rendered, and the energy state is changed, but the fixed update hasn't come in yet. So in this case, we could miss the energy changing, or maybe it could also accumulate values, depending on how the other parts of the program work. So this is not a safe solution. It kind of works, but it's not really a safe solution. Don't worry about it too much, though. Let's just split it up, right? So we get the best, right? So we have fixed update. This changes the energy if it needs to. And then an update, we make sure we don't have any visual lag. We just change the color, and we don't change the stored property. So the physics are fine because the energy is a physical thing, so it moves in fixed update, and the graphics are an update. This is probably the better solution. And as you might recall, we shipped the first one. So let's actually think about, did we need to fix this? You might want to think about this before you fix it, depending on the problem, but let's think about it after. Fixed update versus update. So as we said, the headset updates at 90 to 120 times. The default physics update is 50, so if we have 90 Hertz of the headset updates, so like the Vive Pro, I think, does that, then that would be 8 milliseconds of lag. And if we have the frame that takes 11 milliseconds, so between the frames, that means that we don't have more than one additional frame of delay between each of these objects, okay? So, because So if you have like 90 objects, we'll get there. So you have 90 objects in a row, and you have 8 milliseconds of lag in each of them. At the end of the line, there's going to be a 1 second delay before the graphics update at the last object. So do we need to fix that? Or did we need to fix that? Because you just did. Well, it depends on the gameplay you want to achieve. And it depends on the environment. This is only the code that we've been looking at is very small, right? It's only a single class. In our game, this problem didn't even happen because of SteamVR. And this is what I found to prove it, I guess, because I was searching for, is this happening to other people? Well, SteamVR changes the fixed update at runtime. So you can put whatever you want in the project settings. It's just going to set the fixed update to whatever the headset wants. So for an Index, it's going to be 120 Hz. For the Vive Pro, it's going to be 90 Hz. And the only way you can prevent it is by doing this. SteamVR settings, log physics update to render frequency false. And then jump in a circle, and then it works. In this case, we didn't need to fix it, kind of. Maybe we did, because we also have the same game running on the Quest. I don't know what's happening there, I haven't checked. But the important part is that the game still works. So this was basically an exercise in futility at the end of the day, fixing this right now with you. But the important part is that we thought about the MonoBehaviour callback some more. Okay, does everybody know what time it is? It's tool time. It's an old joke. I've got some useful links for you, hopefully. This is a bunch of stuff, and you can take a picture of this if you want. There will be a link to the slides at the end. This is the resources that I use to learn about Unity all the time. So, especially this one also for inspiration. If you want to find out about locomotion, ideas that people have published. And the YouTube channel here, very nice for getting into Unity. And it's no longer updating, I think, but it's still relevant. Other than that, here are some sources of free and cheap assets that I could mention. So these ones I also use at work. Polyhaven has nice textures, TurboSquid, CG Trader, lots of 3D models, free sound for sound effects, the asset store, of course. And, well, other than GitHub, there's the Russian dark web, but just, know what you want to click on or not. So now we have time for questions. Yes?
I have a question about the public fields and classes. There are a lot of ways how you can get an object that also belongs to a game object. Are you doing this by creating a public field and pulling it from there? Or do you do it with the API that you want to get an object like a DUR?
Mm-hmm. So do you mean an object on the same, is this in the same hierarchy?
Yeah.
Okay, so there's, as you said, you could do it in two ways. Either you put the field in the inspector, or you don't. One note about it, things that you make public, generally, they are public, right? So I would say make something public if you can. This is not a fixed rule, but make something public if you want other people to rely on it. If you're making something public because it should be in the inspector, you're doing it wrong. Just put a serialized field, okay? If you want to get the other components, what they're called, the add component thing, then you can do that in either way. It's honestly fine with me if you do if you drag it in or something, or there's also the little dot you can click. What I've kind of started doing is for objects that really need, like scripts that need each other very much, I put at the top, you can put a class attribute, and it's called require component. And for example, if you add, what is it? Is it a rigid body or something? It always adds a collider for you. So this is the one script needing another component with require component, so Unity adds it for you. And you can do this in your script as well. And then you can, in your code, assume it's always going to be there. because you can't even save the prefab without the other script in it. So you can just in Awake, you can do get component with the class type.
Okay.
Yeah. About the object sharing. So one thing that I haven't shown you because it's in literally every other tutorial is like making a game manager. So that's a way you can also share references to objects. I would use it sparingly, maybe. Like, okay, for this project, whatever. But like generally, kind of try to not have that much spaghetti. We had this museum app at work. Boy, the game manager was probably like 1,000 lines of just references, trying to get them, find them, delete them, whatever. We ended up having a problem where if you close the shop too many times, like you open the shop, you close the shop, then there would be like 3 items, like, or the number of times you opened it, items purchased instead of 1, because of some reference issues. It's crazy. So just try to keep it in a small size. And if you can, then make it, and if it makes sense, then you can use the runtime initialize thing to make it to make your own singleton. That's one thing you can also do. Okay, any other questions?
So they are now teams of 3 to 5 people.
Okay.
They just got thrown together yesterday. Probably some of them know each other, some don't. How do they best start to work as a team in Unity?
So are they going to be working here in the same room? No.
The 2 rooms.
The teams
But the team is in the same room. Okay, good. Let's see. So I think if you have someone in the team who already knows how to set up a Unity project, probably best for them to be the driver. So that's in pair programming terms. Set up the project, talk everybody through what you're doing, or if nobody knows how to do it, you can watch a video together or something. And then after that, figure out what you're interested in. So for the VR game in 2020, I think we had some people interested in like first-person shooter mechanics, somebody interested in physics, somebody interested in graphics, and then we kind of started to split up our tasks in that way. And then, you just kind of have to figure it out from there. There's lots of things relating to managing the code. I don't know if you've gone into source code management at all. I mean, that's another topic, but I think if you, the most important thing is, it depends on what you're using, but create a branch for yourself. I always run into this at work with the colleagues, even they're like working on the dev or the main branch for some reason. That's the most annoying thing you can do. It slows everything down. Like yesterday was yesterday Monday? Yes. Yesterday the tech artist did something and I did something and then Unfall. So just, branching is important.
So are you using Git?
Yes. You're using Git and we have, Git LFS, the large file storage. That's very useful for just for speeding things up. If you can use that.
You mentioned also the student.
Yes, student pack. Yes. So, if you want to have the Unity dark theme, basically, you can sign up for their student plan. And it's on the Unity student plan website. Just search for it, you'll find it, you log in with your LMU somehow, and then you can get the pro license for 1 year, I think. So then you have a black theme and you can even customize the startup splash screen. Another pack that's really cool is the GitHub student, I don't know what it's called. You need to verify to GitHub and then you get access to a bunch of other things, including some storage on GitHub, I think. So also worth looking at that. Okay, so if there are no more questions, I do have one more thing. Is it happening? There it is. So I was actually very irate 2 weeks ago. I was working on a project that I hadn't worked on before, and I needed to look into the prefabs and the scenes, and it was a rat's nest. It was really hard to find out what's doing what. And obviously, you can write these nice code comments, but there's no way, if you could believe that, in Unity to have, like, add a comment. It doesn't exist. And you can't add notes to your scene or something, unless we make it happen. So, as I said, it's all made up. You can do anything you want. This is a small asset that I made at work and that you all can have for free. This is a documentation comment feature for the inspector. So you can add those to your scene. They are saved in the scene. The colleagues can see them. You can even, let's see, there it is. You can choose if it's an info, a warning, or a to-do. It's a little icon. And did I mention it's free? So yeah, you can download it at this link. And so yeah, have a go and have a great week.